All right, so you guys have the definitions, you have the basic concept of limiting reagent, excess reagent, and now we're going to take a look at limiting reagent calculations. And the extension questions are the calculations that you would do, using all of the stuff that we just learned. So I'm just going to use this as our example problem. So I'm going to look at this like I would a stoic question, because it is a stoic question. And the first thing I need to do is get a chemical equation, my reaction. So I know that it's reactants are hydrogen and oxygen, and it's making water. So real quick, I'm just going to rewrite this. H2 plus O2 yields H2O, and it's a 2 and a 1 and a 2. Okay. So again, it's a stoic question. So it's the same thing we've been doing this whole time. It's on a new page and it talks about limiting rates. It doesn't matter. It's all the same stuff. We're doing the same thing, putting the puzzle pieces together. So it looks different because I don't know what I'm doing. Here, let's just pick purple. The different part is when we say, where are we going to start? We start with what's given. If I read the question, blah, 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 containers filled with 10 grams of hydrogen. Ooh, it's what's given, right? And 5 grams of oxygen. Wait, what? I'm being given 2 things. Where do I start? What do I do first? Yes, you start with both of them. What? Okay, you're going to have 2 charts. First chart starts with 5 grams of oxygen. And your second chart, I don't have a thick purple here, so I'm just going to 10 grams of water. Oh, sorry, not water, hydrogen. Don't listen to me, just read. Okay. So normal stoic, the only thing that's different is I have 2 charts. It's like pretend it's 2 questions, and it's 2 questions in one thing. I still haven't even really read what the question's looking for, and it doesn't matter yet because all I care about is that I have a balanced chemical reaction, I write down what's given, and I follow the path. What is the path? I'm trying to go from wherever I started to moles, to the bridge, to what it wants. Right? So I don't care about the end yet. I gotta, find out where to start first. Start at the beginning. Baby steps will get you to where you need to be. So I know that no matter what, my goal is to get to moles. So I'm just gonna do that real quick here. So grams of oxygen, it's O2 and oxygen 16. So it's gonna be 32 grams of O2 for every 1 mole. And hydrogen is gonna be, it's 1.01, so it's 2.02 grams of hydrogen for every 1 mole. Okay, I'm just gonna draw my thing here, and now I got to moles, and now I need to cross the bridge. And what I started with goes on the bottom, so this is O2. So O's coefficient is 1 mole of O2, and over here this is H2, and his coefficient is a 2, so 2 moles of H2. Okay, so now here's where we can pump the brakes and say, all right, what goes on the top? Where am I trying to get to? Where's the bridge gonna take me? And we just have to, read the question. So the question here is asking which reactant, hydrogen or oxygen, is a limiting reactant. That's what the question is I'm trying to answer. And remember back to the last video, what did we define as, how do we know who's the limiting reactant? Hopefully you're all saying out loud right now, the limiting reactant is whoever makes the least amount of product. That's who the limiting reactant was. So in order to answer this question, I need to get 2 amounts of product and I need to compare them. And whichever one's smaller, whoever made them, that's limiting reactant. So what am I trying to get to? I'm trying to get to product. I want to know who makes the least amount. And in this case, there's only 1 product, but if there was more than 1, I could pick one and just go to that and compare the 2 numbers. So let's just go to the product, which is water. So 2 moles H2O, 2 moles H2O. And if I plug those in my calculator, I'm just gonna look at what I've got here. So you plug those into your calculator, and hopefully for oxygen, you get 0.3125 moles of H2O. And if you do the hydrogen one, hopefully you get 4.95 moles of H2O. Now I have so many numbers. What do I do? What do we do, guys? What do I do? What am I trying to do? Go back, stop, slow down, shh, relax. What am I trying to figure out? I'm trying to figure out what the limiting reactant is. Who's the limiting reactant? He's who makes the least amount of product. So who, either oxygen or hydrogen, see, oxygen or hydrogen, which one made the smaller amount of product? Hopefully you're all saying, Mrs. Cook, this is the smaller amount. So oxygen is my limiting reagent, and you would be correct. So the answer to this question, we had to do all this work, is oxygen is the limiting reagent. Okay, so now B says, okay, how much water is produced? What? Okay, so slow down, back up. It's just asking how much water is going to be made. How much water? Well, what am I going? I know that oxygen is my limiting reagent, so oxygen is going to determine how much water can be produced. And if oxygen is going to produce this many moles of water, I can figure out how many grams that is, and that's how much is going to be produced. What mass? So I'm just going to start with what I calculated up here, 0.3125 moles of H2O, and I'm going to convert that to grams because it wants the mass. And I know that for every 1 mole of H2O, mass is grams. And if I look at the periodic table, it's 18.02. So if I put that in my calculator, again, I get 5.63 grams of H2O. And that's my final answer for that question. So just real quick, what did I just do? I know that oxygen is my limiting reagent. He's the one who determines how much product is made. And he determined that this is how many moles of product was made. But the question didn't want moles, it wanted mass. So I needed to just take this number, convert it to grams, and there's my answer. Okay, so if you're like, oh my God, I don't know what's happening, stop the video, rewatch it. Watch it as many times as you need to, and I promise, and it's gonna click, I promise. You just need to follow, and I know I'm kind of talking fast because I have limited time, but you can rewatch this as many times as you need to until you get it. Now, finally, which reactant is present in excess, and what is the mass of that? So obviously, if oxygen is the limiting reagent, then hydrogen is in excess. And what mass of hydrogen remains? Okay, think back to the problem we did up here. How did I figure out how much was left over? I went from limiting reagent to excess reagent. And that's exactly what I'm going to do down here. I'm going to go from limiting reagent, which is O2, to the excess reagent, which is, H2. H2. And it wants to know mass. So my end goal here, obviously, I start with what's given. I'm given 5 grams of oxygen. So, too far. So I'm going to do, for every 5 grams of oxygen, how many grams of hydrogen is he going to consume, is going to be used up? How much hydrogen, will be converted to water? So for every 5 grams of O2, that's a 30, sorry, I don't know why things are popping up on my screen. That's going to be 32 grams for every 1 mole. Now I cross the bridge, and my ratio is 1 mole of O2 for every 2 moles of H2. And the question wants mass, so I'm going to end in grams because grams is mass. And for every 1 mole of H2, I have 2.02 grams of H2. And if I put that in the calculator, I get 0.631 grams of H2. Oh no, I have 30 seconds. Okay, so real quick, if this is how much gets used, then if I want to know how much remains, I just subtract. So I started, if you look up here, with 10 grams of H2, right? So, oh gosh, now what did I do? Oh geez, oh Pete's. I don't know what just happened. Oh, I'm over here. Crap, I'm gonna run out of time. And I just do 10. 10 minus 0.631.